All right, thanks everyone for joining. I'd like to introduce Dr. Kate Dutton-Regester. She's the wildlife ecologist and lecturer at UQ Gatton campus, focusing on echidna ecology. But before we begin, I'll briefly do a acknowledgement of country. UQ acknowledges the traditional owners and their custodianship of the lands on which we meet. We pay our respects to their ancestors and their descendants due to cultural and spiritual connections to the country. We recognize their valuable contributions to Australian and global society. For this ado, take it away.
All right. Morning, everybody. As mentioned, I'm Kate. I wear a couple of hats. As mentioned, am a lecturer at Gatton in the vet school. I also do a lot of work with Wildlife Queensland, more in a volunteer / getting some more small pots of funding, which enables me to do some echidna research. So I kind of sit there as a bit of a project officer, but it's not an employed role. It's more sort of volunteer capacity, but it ties in obviously really well with what I research. So it's kind of a nice collaboration. They have the Echidna Watch program there, which is what I monitor. So I won't go through the acknowledgement, but just recognise that the echidna is known as Binba in the Yagara and Turrbal languages. So I like to sort of just talk about my journey with echidnas. Before I did my PhD, I never gave echidnas a second thought. They were so far from my radar. I had honestly never ever considered echidnas. So somehow I landed doing this PhD on echidnas, and I was introduced into how awesome they are. There's so many incredibly unique things about echidnas, and I'll sort of slowly walk through those this morning if you don't already know things about echidnas, but my PhD was on their reproductive physiology. So I worked at London Wildlife Sanctuary. They've got a purpose-built breeding facility there, so I worked really closely with those echidnas there. So that's where I started, and as I mentioned, I worked on their reproductive physiology. So just an express sort of 3MT version of my PhD. What we were trying to understand, and we know so little about the echidna. Less than 5 years ago, we didn't even know how long gestation is in the echidna. I know, everyone's jaw drops. It's incredible how little we know about our own species in Australia. So that was kind of the goal of my PhD, to try and determine how long is gestation, and some other cool things about them as well. So we were taking blood from them every 2 to 3 days, and that was to map their hormone profile. So progesterone is the hormone of gestation, so we just wanted to simply map that. And I also had to watch a lot of echidna behaviour. So a lot of seeing what the boys and girls were getting up to when they were partnered. So they had video surveillance installed in every enclosure, up high to observe the whole enclosure, then also one inside what we call a burrow box. And a large part of my PhD was watching echidna behaviour, looking for those confirmed matings. So I needed to see those confirmed matings to be able to go day one. And then I'd have to watch every single day after that to try and find and watch that day of egg laying. Those two endpoints had never been observed before in the same female. So that's what I was doing during my PhD, basically, and then collecting the blood every few days as well, so that we could map the progesterone profile between those 2 points. We were also doing ultrasound to see when we could determine or find the egg in utero, and also obviously to determine that the female was pregnant. An interesting thing about the echidna, one of many interesting things, the pouch is temporary and it only develops during gestation. So we were also monitoring that, looking at the changes, and also trying to determine what controls that pouch development. We still don't know. That was one of the unanswerable questions from my PhD. We still don't know what controls that pouch development once they're pregnant. We were also, so we're sort of running hypothesis that we haven't got a clear answer on yet, but have pretty good indication that body fat is really important to female echidnas. So I'll show you something about that soon. So I can't remember how many echidnas or how many breeding cycles, but quite a few, match the progesterone, and this is what pregnancy looks like in a hormone profile. So this is progesterone. Day 0 is the day of confirmed mating, and you can see your progesterone increases, shoots up, and then starts to decline, and the egg is laid. It's about 16 to 18 days after confirmed mating. So that was very, very consistent across the 16, 20 different mating profiles I saw. 16 to 18, never any less, never any more. Really, really consistent between that very defined window. So I was talking about body fat being really important. So in the wild, females, we think from studies that have been done, only reproduce every 2 to 6 years. So what we've got up the top here, we did, these are MRI scans. Up the top here is a male. So this is actually after, and then this is before a breeding season. But you can see there's not a lot of change in fat between those. I do like to point out, you can see the male testes increase in size leading into the breeding season. So essentially what happens outside of the breeding season, their bodies shut down, testes regress, the hormones, for reproductive behaviors are not circulating so much, and they essentially shut down. But when it is getting into becoming breeding season, all those systems start taking off, and the male's testes will increase, and testosterone and everything obviously increases. But for the female, so this is a female that went through a full breeding cycle. So she went through courtship behavior. Has everyone heard of the Echidna train? So a whole bunch of males will follow a female in hopes to mate with her. And that training behavior can go on for some time. So we only ever had one female and one male in an enclosure, but they would still do that behavior. The male still follows the female nose to tail, and he will do that for up to 30 days and non-stop. I watched males following females day and night from 4 p.m. in the afternoon through to 7, 8, 9 the next day. It is pretty intense. It disrupts, she's burning a lot of energy in that, trying to, I guess, evade the male, because if she stops, he just tries to mate with her. She tries to eat, he tries to mate with her. So you can see she's burning a lot of energy. She's not getting a lot of nutrition in as well because of this sort of disruptive behavior from the male. Then when they do mate, she's pregnant. That's obviously a highly energetic life event. So she's producing this egg. She's also starting to produce the milk that she'll lactate the young. A lot of energy going, burning, doing all this. And then when she lays the egg, she then incubates it for 10 days, during which she does not eat at all. So you can see it's really highly energetic, energetically expensive for a female to go through a reproductive cycle. So this is her at the end of a reproductive cycle. She would have looked like this leading into it, and then ended up like this at the end of it. So you can see that by the end of the breeding season, she's lost a lot of body weight. And so you can imagine in the wild, it's probably going to take quite a few seasons to build that body fat back up to get to a nice body fat to be able to reproduce. In captivity, we actually feed them a high-fat diet and purposely fatten them up, and we can get them breeding every single year, year after year. But obviously we can't do that in the wild. So that's sort of still a working hypothesis, I guess, that we have that body fat is really important for the female. So after my PhD, looking around for a job after PhD, I went and volunteered with Wildlife Queensland, and they've had this Echidna Watch program running for about 10 years. Some volunteers set it up a long time ago, and then it kind of got abandoned because that volunteer left and there wasn't someone to sort of continue it. And they had 7 years of data just sitting there. It's a citizen science platform where people can report their echidna observations. And so all these observations had been coming in through the platform for 7 years, and nobody had looked at them. So I came in, looked at all these observations, got them all in a spreadsheet, and get all these incredible images coming through, which I really like. You can see how diverse echidnas are in their coloration and everything, and where we see them as well. We get quite a lot of echidnas coming up in people's backyards and various other places. So I went through that 10 years of data, and a very consistent message I was getting from these observations was people saying, I've lived here for 10 years and I don't see echidnas like I used to. I was repeatedly getting this messaging come through, and that really triggered in my brain because all I had heard through my PhD was that they're common. They're common, they're everywhere, they're common, we don't need to worry about them. And then I'm going to this data and I'm just getting repeatedly this message, we don't see them like we used to. So that triggered a bit of an alarm bell in my head that perhaps they're not as common as we think. And, where is the data that people are coming up with this expression that they're common? There's actually no data at all. This is a map just of Atlas of Living Australia of all observations of all time. So people see something like this and they say, oh, they're common, look at that. And they're everywhere. So also apparently them being everywhere somehow equates to they're common. But I still question, where's the data that says they're common? As a scientist, I need some data to show me they're common. Not these assumptions that they're everywhere, so they must be common. So been doing some digging in the available data, which is only what's on iNaturalist or ALA, and by LGA, you can see this is 2024, so just 1 year. That's not a lot of observations, right? That's all the data I've got to work with year by year. The numbers are like this. It's not very many. So a population of echidna that has been well studied. So there are different subspecies. The kangaroo island subspecies has been really well studied by this lady here, Peggy Rismiller, and she studied them for 10 years and they came to the conclusion they're endangered. So what's to say the same situation's not going on in Queensland? Because we don't have the data. They also didn't have the data in Kangaroo Island, but somebody collected the data and they came to the conclusion they're endangered. Key threats. I work with a lot of wildlife hospital admissions data, probably quite obviously getting hit by a car and dog attacks are primary threats to echidna outside of habitat destruction and all that sort of stuff. But they're the primary reasons echidnas are coming in. I also have a bit of a concern around climate change. So the echidna, like the platypus, the monotremes, their body temperature is 32 degrees. It's lower than other mammals. So they're very sensitive to heat. They will actually die at temperatures of 35 degrees. They just can't handle those extreme temperatures or those high temperatures. So when we've got climate change ticking around and our baseline temperatures increasing, this is kind of a concern to me. What's happening to echidnas? Last year in August, we were already hitting temperatures of 35 degrees. Winter here in Australia from late May through to early October, that's when echidnas are active, when it's cool, when it's supposed to be cool. That's their breeding season, that's when they're active. Who's seen an echidna? Do you ever see them in summer? They're just not active in summer. Maybe dawn, dusk, and at nighttime, but you generally do not see them. I see it in the data through Echidna Watch. When it hits May, I start getting slammed with observations of echidnas. When it hits 30th of September, suddenly it's crickets. There's not much. They are very programmed to be only active in those cooler temperatures. So if we're seeing 35 degrees in August, which is still winter, which is still supposed to be the echidna breeding season, how do you think they're going to cope with that? Is that going to have effects on constricting their breeding season to start shortening it? And then they're already only reproducing every 2 to 6 years. What sort of effects does this have for the longevity of the species and their reproductive potential? I find that really, really concerning, that there's potential constriction in their breeding season and therefore longevity of the species. And then there's another whole potential threat, we're not sure, fire ants. So echidnas love to eat ants, termites. So what kind of impact are fire ants having? Can echidnas eat them? Don't know. We're exploring that. If they do eat them, is there any sort of negative consequences? Or is it more that potentially they get attacked while they're trying to eat them? Or are fire ants simply just pushing out native ants and so reducing food availability for echidnas? I've already got wildlife carers telling me that they're getting echidnas coming in malnourished, which again is ringing alarm bells for me, that there's complex things going on in the ecosystem that have some pretty significant concern regarding echidnas. So massive gap. We don't know how many there are. There is no baseline. Most observations are coming from citizen science, which are great, but obviously they're really biased towards where people are hanging out, so those urban sort of areas. So systematic data collection across the board is really what is needed. So this is what has sort of established what we call Echidna Conservation Building a Baseline, which is my sort of core research program, where we are trying to determine how do we find echidnas, how do we count them, how do we build this baseline to understand how many there are so that we can monitor them moving forward to understand how all these threatening processes might be affecting them or how they're coping with them. So the sort of aims are this is a great picture someone sent in through Wildlife Queensland's Echidna Watch. Echidna popped in the backyard. Trying to determine, I guess, some sort of estimation of their numbers in southeast Queensland. How populous are they? How abundant are they? Simple things like what sort of habitats they like to live in. We don't even know that sort of basic information, We know they're sort of found generally everywhere, but are there certain habitats that they like? Is it dictated by where their food sources are and things like that? Like I've mentioned, is there potential constriction of the breeding season going on and the fire ant impact? So these are sort of all some things we're exploring. With that, how are we doing it? Poor echidnas have really been left under the radar. As I've said, we've got no data on them. One, I think they are very, very hard to study. And we are still finding that even with all the technology and things that we've got around currently, that they're still really hard. I've got several students on board and they attempt to study echidna and they get really frustrated. Why aren't we seeing them? Where are they? It can be a really frustrating endeavour to try and study echidnas. So I think one reason why we don't have any good data on echidnas is that they are really hard to study. Another reason I think that really heavily feeds into it is just that assumption that they're common. We've been with this assumption that they're everywhere, they're widespread, so they're common. So they've kind of slipped under the radar a bit. So naturally, funding doesn't really come to a species where we think it's common. No one wants to fund a species that we think is common. So funding doesn't really come easily, which makes things obviously quite challenging. But what we're doing is really trying to partner with community groups and volunteers to get, I guess, that citizen science power, getting people involved, A lot of land for wildlife properties will help us out. They've got their own cameras and things like that. Other researchers feed into us as well when they've got cameras out telling us when they've seen echidnas. Community groups who are out doing bush care and things like that, they help us look for scats. What we'd really like to try and do is collect echidna scats so that we can look at their diet, but also their genetics as well. They could be common, that's great, but are they genetically healthy is another whole question. So we are trying a whole bunch of tools, from detection dogs, camera trapping, we're trying thermal drones, we're trying everything basically to try and determine what are the tools that are best suited to helping us find and count echidnas. So we're partnering with a couple of groups, and with them we've trained the world's first echidna scat detection dogs. That within 5 days. Within a week, pull out, get it down with a hidden echidna. So, this is Jara as well, the other dog that we've trained. They're both incredible. We've had them both out in the field for real, looking for echidna scats that we haven't hidden for them to find. And Cola found 7 in a couple of hours on one of her test runs a few months back. So really powerful tool for us to help us find echidna scats because they are really hard to find. Echidnas can tend to bury scats, which adds another layer of complexity. There's layers and layers of complexity with echidnas. But the detection dogs are a real game changer for us. Jara is in the process of being trained to detect live echidnas as well, and I think that will really help us detect them as well. So, echidna scat, does anyone know what it looks like? No? Not many people do. So they are quite unique. They are quite large, a lot larger than you would probably imagine. So I like to compare it to a cocktail frankfurt. Quite similar to that. That's kind of my best comparison to visualize. They're about 5 to 7 centimeters long, so they are quite large, and about 2 centimeter diameter. So they are quite sizable. So that's something important to keep in mind, that they're probably bigger than you think. I go out into the field with some students who are just starting out, and they'll find these little twig-like cylindrical, but very twig-like. And is this an echidna? No, a lot bigger. Think cocktail frankfurt size. Like, they are quite large. Another really cool thing is that if you're not sure, break it open. If it's full of feathers and fur, it's not echidna. Ants and termites, bugs, those sorts of things. If you break it open, you'll see all those exoskeletons from their diet. And if you really want to be sure, take it home, get in a dark room, shine a torch, and it sparkles. It's actually like glitter poo. It's really, really cool. The scat is really quite unique. But again, we have that challenge that some echidnas do bury it, some don't. We are on the lookout for scats and for people to send it in to us, because we'd like to, look at them for diet. There have been echidnas found eating the eggs of turtles as well, which is quite a new development in recent times. So we starting to explore that their diet is maybe more varied than we have actually thought. Really interesting stuff. So trying to get echidna detectives on board. Anyone and everyone could be an echidna detective. If you're out for a bushwalk, out walking the dog, any sort of things, be on the lookout for echidna scats, particularly through that sort of end of May through to early October period. That's when they're most active. Their activity dramatically drops off over that time. So yeah, there's the go card for that size comparison as to, you know, that how quite large they are and that nice shape. So we're using various tools, and I just want to actually comment. So what do echidnas do in that time where it's not breeding season, it's not winter? Does anyone know what they do in that period outside of that? No, you probably do. So this is another amazing feature of them. They can thermoregulate. So they can lower their body temperature to 5 degrees and literally chill out over summer. So they'll just dig down, drop that body temperature and just chill. And it's either a state of torpor, so they can just do it sort of low level and come up at night time to get a bit of a feed and then go back down. They can be very inactive. In captivity, I would sometimes just see an echidna just literally come up for food and then go back down. They don't do a lot over summer. Some of them can go into full hibernation as well, where they'll be gone for days, weeks, months. So they literally, you know, and it's a superpower. It's a real superpower to be able to just go, it's too hot, I'm beating the heat, I'm going down, and you're not going to see me until, you know, next breeding season when the weather's cool. So yeah, really quite a cool characteristic. So some other tools we've been trialing. This is from a handheld thermal tool. It's just really cool footage to show. Marshmallow. So my students have been out. This is one of our core study sites where we've found quite a nice population of echidnas. They went out this past breeding season and just been hitting it really hard with all the different tools. So this is some really cool footage and things that they've been capturing. This is just a red light torch, which just obviously is better for the animal, but you know, helps us find echidnas as well. And if you look at this one over here, you can see his cute face. So they like being around logs and in rocks and things like that. Concealed. My students have been amazing at being able to find echidnas. They call themselves the echidna stalkers. They've become really quite good at it. Yeah, so otherwise, we're just getting camera traps out there as much as we can. Again, it's sort of just building up that collection of cameras. I've been quite lucky this year to get quite a lot of, I won't say a lot, but several small pots of funding, which has enabled purchase of cameras. And we're sort of doing it in a systematic approach, getting the cameras out there to try and get some sort of baseline understanding, mostly in, I guess, more urban habitat fragments at the moment, just because resource-wise and everything, it's a bit harder for us at the moment to be out in more massive conservation parks and things like that. The aim is to get there, but yeah, obviously that's a bit harder with resource and things like that. I sort of started this whole initiative by myself, and somehow I've gotten a bunch of students who are keen and on board, and so it's just grown and grown and grown. And you know, every week it's growing and changing as to what we're doing. So we're definitely expanding and trying to get as much coverage as we possibly can. So what's ahead for 2026? We're doing an eDNA pilot. I had the eDNA people reach out to me. I posted this picture on, actually it wasn't this picture, it was a picture and there was an echidna climbing all over a termite mound, and they got very excited and said, oh, have you thought about eDNA? We could do something with this, because echidnas are obviously digging around termite mounds and things like that. So we're going to pilot collecting dirt and things that around termite mounds to see if we can detect echidnas using that. So I picked up some funding to fund that, which is nice. And then, yeah, some scat genetic analysis as well. So next winter, the next echidna breeding season, really want to try and activate people to get out there, help us find those scats, and we'll be getting the dogs out there as well to do some genetic analysis. We've got small pot of funding for that, but it's going to be a limited number. But yeah, the more we get, and just talking about echidnas and to councils and things like that, I think people thought I was a bit crazy to start with, because they're saying, you know, they're common, why would you bother studying them? And then I show them the data and they go, oh, okay, we understand you now. We also have on board long-beaked echidna in Papua New Guinea, partnering with, this is Muse from over there, who's the only person in the world who has studied the long-beaked echidna. It takes like 300 man-hours just to find one long-beaked echidna. He was in Australia recently, and I was telling him about what we're doing with the short-beaked echidnas here, and his eyeballs popped out of his head, and I said, I know, we need to get these tools over to you. So we're currently talking about this, making it happen so that we can study the long-beaked echidna. Again, if you think the short-beaked echidna is hard, long-beaked echidna are even harder, even less data. But with these tools, there's more potential for us to be able to find long-beaked echidna and start looking for them and studying them. We literally know nothing about them. There's 3 species of long-beaked echidna, and they're all critically endangered. So really important. And it's really good to see that these technologies and what we're learning about the short-beaked echidna is potentially transferable and applicable to the long-beaked echidna and helping out that critically endangered cousins of the short-beaked echidna. So if you have camera trap data, I know a lot of people here are researchers and things like that. If you do have camera trap data and you're open to sharing it, please do let us know about echidna observations. We really need the more data, the more we can do with it and understand what echidnas are doing, where they are, all those sorts of things. So basically that's it. Thanks for listening. Acknowledgement to all the funders of the program so far, which is the local city councils. Australia Post chucked in a couple of grand as well, bit of a random one, but money's good. The Wet and Hall Environmental Trust, really appreciate them being open to funding my idea. I know when I applied for that grant initially, again, it was that, but echidnas are common. And so I really had to state my case. And again, it's just showing them the data. This is the data we've got, nothing. It's good to see that people are opening their eyes and seeing the value in monitoring echidnas. And on the side, when I have time, which I don't, but I do, I make some wildlife cushion things and sell them, and the funds sort of feed mostly into, I guess, wildlife carers and things to help them with wildlife, but it can help with the echidna research as well. Good Christmas present idea. I have a bunch more fabrics and things, if you're interested. My email.
Awesome talk. There should be plenty of time for questions, but as the host, I'll take one question right away. Just out of curiosity, and I think I know the answer is probably no. Has there been any individual radio tracking or individual echidnas?
There has, but it's very hard. We are interested in doing that, but it's just finding the right tech. But I think we have. So now it comes to funding. So now it's just funding. So the other population or subspecies that's been really well studied is the Tassie population. So there's lots of good data on there, and I think they've done some radio tracking in the past. There's a vet in, I think it's Ballarat in Victoria, who's currently tracking echidnas. And, I've been racking my brain, how the heck, where do you put it? She's been putting it on one of their spikes. Oh. So she started doing that and it was quite unsuccessful. It would fall off within 3 days. So it's like a glue that is used. So she's worked out some technique that helps it last a lot longer. So I'm in conversations with her, like, how do you do it? Give us the instructions. So, because if we can get some more funding, we'd like to actually track them as well, because that'd be very cool.
Yeah, definitely.
And important. Yeah. Yes.
Me or somebody?
You.
I have a couple of questions online.
Okay.
Liz Foote has said, hi, thank you for sharing that. It's a great initiative. I'm wondering if you coordinate any specific volunteer engagement events. That is, how do you recruit new volunteers, and if you measure and track volunteer involvement in any way?
Yeah, definitely open to anyone emailing me interested in volunteering. I have several students working on a number of different projects, so they always need volunteers. So there's plenty of opportunities. Sort of in the process of trying to set up, I guess, a web page to make it a bit more formal and easier, and I should track, but I don't do a very good job of that at the moment. There's just, juggling a lot of things, and it's sort of in the process. I'm hoping before next breeding season, we'll have mastered all of this and have all the right things implemented, and an avenue for potential volunteers to sign up and all those sorts of things, and to just see all the projects we're doing, and to track volunteer input and all that sort of stuff.
I have a second question from Christina. Thanks for your important work in this space. I was wondering if you know if Echidna's introduced Argentina ants.
Don't know, but I'm going to probably say yes. I think the fire ants are the only one where it's an unsure, because I think generally most ants have formic acid, which is the chemical that they will bite and, sting you with, and that's pretty low level, and echidnas can handle that. Whereas in fire ants, it's I forget now, an alkaloid or something, and it's obviously a lot more intense and toxic. So there's a question mark there whether they can handle that and metabolize it, or what the dynamic is there. So I'd probably say yes, but I don't know, don't have any evidence as to yes or no.
Do you want to go first? Thank you for the wonderful presentation. That was really, really interesting. My question was, are you guys planning on doing population viability analysis of any of the populations, or is that kind of difficult because we don't know the metrics of fecundity or stuff like that?
Yeah, I mean, it would be great. As a starting point, I guess, for now, we're just trying to understand what are the best tools to use to monitor them, count them, where are they? Again, we just don't even have that understanding or baseline data to tell us where they are and to do these sorts of studies. So it's kind of just mapping out what's the baseline of what's going on with them. And then once we understand that, we can do these deeper studies. Yeah.
Thank you.
Okay. Yeah.
With your work at Coromba, did it confirmed mating always lead to a pregnancy?
Yeah. So my supervisor had a bit of a theory that they could do sperm storage like reptiles, but we never saw any evidence of that. Yeah, it was always confirmed mating, always an egg. Yeah.
I've got an easy question and a dumb question. The easy one is, for the scat samples, are you wanting them Australia-wide or just Southeast Queensland?
At the moment, preferably probably just Southeast Queensland. I mean, it's just funding. I mean,
Okay.
if we get funding, it's going to be limited.
Yep.
And at the moment, we're just focusing on Southeast Queensland.
Yep.
Yeah.
And the dumb question, because I'm the least biological person in the room, is the pouch thing, when they get the pouch, so after they've done with the breeding part of their life or at the later end, does it do anything weird, or they're just hanging out?
Pouch?
Yes.
Yeah.
Weird. Obviously the pre-pouch life is interesting. Is the post-pouch use?
It just
life?
regresses.
It regresses.
It's just back to normal.
Okay.
Yeah, and they'll make it again when they're pregnant again.
That's crazy.
I know. Echidnas are wacky.
Okay.
There is. I should have looked this up. If you read my paper, there is another species that does do the temporary pouch
Right.
as well. I can't remember off the top of my head what it is. So they're not the only one. But again, it just regresses. But
What does a half regressed hatch look like?
I wish I had
a
a picture.
But some weird.
It looks when it's regressing, because there's two lateral folds of skin here, and that's what becomes really turgid and swollen.
Yeah.
When it's regressing, they get, I don't know how to describe it. It's just become really thin and flappy. It looks really gross. But yeah, eventually just goes back to normal. Yeah, it's quite interesting. Yeah. And we don't know what controls it, and we're not sure if even there's some sort of mechanical receptivity to know, because they lay the egg, she rolls it up with her beak, pops it in the pouch, and then it just clamps shut. And it is really strong muscular arrangement there that must clamp it shut, because to peel it open to look at the egg, you really have to sort of force it apart. Yeah. So.
I also may have a smart question at the end of the question going with the theme. So the first question I'm going to ask, it could be the smart or the dumb one, I'm not sure, but why are Echidna, why is the back feet backwards? What is that?
Okay.
Freeze time?
It's just to help them dig.
Oh.
So it's another. It's so hard to study.
Yeah.
So the backwards, so the front paws, back feet, whatever you want to call them.
Yep.
Essentially, it just helps them drill down. They can disappear in seconds, and it's because of that foot arrangement that they are like a drill. It's just straight down. Yeah.
Okay.
Yeah. So they can disappear really quickly.
That's really cool. And then my dumb question is, how do echidnas mate? Because they're spiny on us. Or are they they flip over, just one of them flip?
Call it a C shape. So the female will be like a C, and the male would just lay behind her like that. And
Thanks.
you get a picture.
Yeah.
I have lots of footage if you would like to. Mating itself can last quite a long time. We had as short as 20 minutes, and I did see one for 2 hours as well. Yeah. Yeah. So again, it's is duration important to that whole reproductive process, getting enough sperm and everything and all that sort of stuff. Again, just a whole bunch of unanswered questions when it comes to the echidna in general.
Really fair. Well, thank you.
Question about the sort of basic life history observation that you do. I worked on a very common European songbird, and the species has not been studied, but if you want to look at published accounts on the behavior, you have to go back to the 50s, because at this time it's no longer sexy enough to publish just observation. So do you have any issues publishing, or sort of what's your experience with providing this very basic necessary data which seeds how to publish sometimes?
Interesting. Haven't had a lot of issue. I mean, to date, I haven't published a paper on echidna since my PhD, which was 3 years ago when I finished. It seemed to be fine. Fundamental biology, of a native species, I didn't see any. We didn't have any resistance or anything. Same sort of scenario. A lot of research is from quite a while ago, which is quite interesting that there's hopefully a new wave of research coming up. And I guess the research we're doing here is, more field applied, which I think the only challenge for me is that I'm not an ecologist. So I think that's where I have a bit of a struggle, in that my head knowledge is not in ecology. I feel like that's my challenge.
You were sort of concerned about climate change and echidnas in general. Is there anything specific about their reproduction cycle where increased temperatures would cause an already pregnant female to have some sort of issues around?
Good question. We don't know. I mean, if temperatures were getting too hot, would she abort it? We really don't know those sort of things. They're all good hypotheses and questions to explore, but yeah, we don't know.
No, is there sort of the thermal regulation you were talking about, otherwise,
Okay.
like totally able?
Yeah, dropping down.
Yeah.
So interestingly, the Tasmanian subspecies. So the subspecies are all a little bit different. The Tasmanian one in particular. So mainland echidnas all tend to do that training behaviour. The Tasmanian subspecies, because the climate's obviously a lot colder there, they will go into proper hibernation, and the females will pretty much stay down there through the breeding season and won't really come up unless they do engage in reproductive activity. But the male will resurface sort of mid-May when their testes are starting to enlarge and the testosterone circulating. And when they're ready to mate, they will somehow locate a female that's underground and wake her up to mate with her. Yeah, so yeah. So where was I going with that? So the females can actually, once they're impregnated, and this has only been observed in the Tasmanian subspecies, they can actually, what's the right word? Sort of like diapause, like pause the pregnancy. So their body temperature will reduce because they want to keep chilling out, whatever, for a couple of weeks, and then they'll come back to normal body temperature and the pregnancy will continue. And that's normal for them. So whether mainland ones can do it as well, we have no idea.
Yeah.
But the Tasmanian subspecies can, which is super, super interesting. Yeah. Yes.
Christina has another question. She was wondering why an echidna on Magnetic Island, which is in a hot region, had like only 5 spines. It otherwise looked healthy. It was with Puggle, but as a precaution, they took it to a carer who sent it to the mainland in Townsville. They found no skin issues or any health issues, so they simply released it back where they found it. Strange observation, right?
Really interesting, yeah.
Just got a picture as well.
Incredible. Obviously being in some sort of trauma, right? Did they look like they were broken off or just naked?
She can't unmute, but maybe she'll time.
Yeah, okay. Yeah, interesting. I've seen echidnas with no hair or heard of them, and that seems to be alopecia. There's a vet clinic in Northern Rivers in New South Wales, and they're saying they're seeing echidnas coming in with no hair, and when they get them tested, it's stress-induced alopecia. But yeah, no spikes. It'd be interesting if it's broken off or if it's actual naked.
Christine says, looks like a skin issue, no broken spines. And if you could take a look at the image, that should answer your question.
Okay.
So I'll show you.
Is it up here? Or?
That's
That's
really
really interesting.
That might make reproduction more easy.
For the male. But then it would expose them to dog attacks and things like that. They'd be much more susceptible. Super interesting. I have no idea about that. I'd love to see the picture though.
I'll find it, chat to you later.
Yeah. Yes.
I was wondering about the pouch of the temporary pouch because they like to dig. Is it forward facing or backwards facing?
Not really either.
Okay.
It kind of just is like this. Like just,
Okay.
yeah.
So it's a bit different than
Yeah, to
Yeah.
a wombat and yeah.
fair.
Yeah.
Cool.
Yeah. It really just closes so tightly that the egg and the young just sit in there. Yeah, it's quite remarkable. Yeah.
I've located that pic now.
Okay.
It's a tiny picture.
Have any spots? Interesting. Monitoring it? Is that Christine? I'll contact her. Very unusual. Yeah.
Thanks.
Will you share it?
Sorry. I don't think I can, but I can email it later.
Yeah.
Does anybody else have any questions?
It's not a question, but I just want to say thanks for an amazing talk, and I have learned so much.
That's
Thank
great.
you.
Excellent, thank you.
And I'll buy some cushions for you.
Oh, perfect. You have a question?
Yeah, nice looking at big dogs and big ones. You've looking at all your fund curve acknowledgements there. I think it's the RAC people that I've heard at the paying for the use.
Yeah.
To that, there's that.
This is a big gripe of mine. So many people use the Echidna. Why is so many different places and they do not fund Echidnas because it's common. Why would we fund Echidnas? The same
Price funds for themselves.
I know. I see it everywhere that the Echidna is used so much, and then I go, why aren't you funding Echidna research? Yeah, it's very frustrating. Yeah. Yes. The breeding season supposedly is very, very consistent across the board. But recently I'm a little bit confused because on Facebook I'm getting a lot of echidna stories and things like that from Victoria and New South Wales, and they're suggesting that the breeding season is starting now, which is not what the literature says. So I'm a little bit unsure if they've got their wires crossed or if there is some sort of shift in seasons or something. I'm not really sure. It's something I'm exploring as well. But yeah, as far as I know, across Australia, the breeding season is very, very consistent for echidnas. It's one little spike. That's so strange.
She said it looked more like a skin issue.
Yeah. Interesting.
See, America, like, or I guess Eurasia, like hedgehogs that get that same kind of thing, and they just kind of look like little wrinkly guys that have to moisturize them regularly so they don't dry out.
Is that a skin condition as well?
In the hedgehogs, yes,
Yeah,
I believe it is.
Interesting.
Anybody else have any other questions? Not. I'll thank Kate for very interesting.
Thank you, and thanks for having me as well. It's always good to talk about echidnas.